Okay, so here we can see that the Lagrangian for a certain system, for a mass spring system, so just a simple mass with a spring, the kinetic energy is mv squared, 1/2 mv squared, which is x dot is v, and then the potential energy v is 1/2 k x squared, so where x is the position of the spring. So let's take a look at that. So in this case, our system is simply a mass with a spring, and we know that t equals, okay, so let me do a reference point for unstretched. This is the x direction. 1/2 m x dot squared. This is the kinetic energy. And v is 1/2, oh, forgot to write k. K x squared, which is the potential energy. And now the Lagrangian is t minus v. So in this case, our Lagrangian is 1/2 m x dot squared minus 1/2 k x squared. So this is just like any other function of two variables. So we can say, like, imagine you had z equals x squared plus y squared or something, and then you would just do, you're going to plot z, so it's a three-dimensional surface, so you have x and y, and then you just in this case it would be parabolas in both directions going up, so you're going to get some surface like this, right? So in this case, we're doing the exact same thing, except our variables are x and x dot, and it goes up. This is called Lagrangian. So it's going to be some, sort of surface here. And we could plot this. You can actually just plot this in Google. If you just punch this equation into Google, you can get, so let's say we want z equals x squared plus y squared. This will show you a graph, right? So this is what I was trying to draw here. Here. Okay, so now I'd like to try to recreate some of what I saw in Eugene's video in Blender. Okay, so now my goal is to be able to plot surface plots such as this in Blender, so that I can try to recreate some of the things that I saw in Eugene's video. And I'll be using an example for a simple mass spring system. And as you can see, the Lagrangian is 1/2 m x dot squared minus 1/2 k x squared. So we just want to generate a plot for this in Blender. So I'm going to make it simple and say that m equals 1 and k equals 1. So then we just have L equals 1/2 x dot squared minus 1/2 x squared. Okay, so now we'll go into Blender and I'm going to delete the cube. Now we're going to add a mesh that takes a mathematical function. So let me show you the add-on. Go to add-ons, user settings, add-on, hit extra or search extra, and check this, add mesh extra objects. Make sure you check that and then hit save user settings. And you can come in here and make sure your cursor is in the center, and let me turn on key cast. All right, make sure your cursor is in the center, and then you can create math function z math surface. So it says add a surface defined by a function z equals f of x and y. And that's exactly what our Lagrangian is. It's just a function of x and x dot. So we'll have y be x dot. So the default function that it creates is 1 minus quantity x squared plus y squared. So we don't want that. We want 1/2 y, which is the velocity x dot squared, minus x, 1/2 x squared. Right, because we're calling this is x dot, this is x. Okay, so let's see what that would look like. It's a saddle. So now I'm going to make this a little bit bigger. I'll make this 5 by 5. So you can see if I hit top mode and orthographic, this is just a grid. And then the height of the vertices is controlled by this mathematical function. All right. So now we've got that. One thing about this, I don't know how to go back to edit if I want to change anything about the function or subdivide this further. You can only really do that once, and then once you start messing around and going into different modes, that's gone, and I don't know how to get it back up. So if someone wants to let me know if there is a way, that would be awesome. All right, so let's go into edit mode, and what I want to do now is actually, hang on. So first I'm going to do this. I'm going to create a material for this, and I want to be in cycles, use nodes. All right. So the idea behind this is I want to have this graph be colored, so like red down here and green up here and yellow in between. So we can show the value using colors, and then we're going to eventually change the color value to be the partial derivative in the x direction, the partial derivative in the x dot direction, just like in Eugene's video for the example of a mass spring system. So let's first change this to the node editor so we can mess with this material. All right. So use your center wheel to zoom in, or scroll wheel. All right, we're going to add a object info. We need the info of the location. Now, if you're saying that this is going to work, this is all just one object right now, that is correct. But we're going to be subdividing this based by the edges and turning this all into a bunch of different objects. I just want to make sure that all the objects have this material information first, so that it'll work when we do that. So we have location, and then we only want the z location. So go to add converter, separate x, y, z. It's shift A to add, by the way. And then we're going to connect this, and we only care about z. And then now we want color ramp. And let's put it into material view so we can start to see the color. Okay, so already it's working. We can see that, right? Like I said, I knew it was going to be at 0 because this origin is at 0, but once we move it up, it changes color according to the color ramp. Okay, so next thing I want to do is I want to change this to be red. So it'll be red at the bottom, and I want it to be green at the top. Make sure these are zeroed out. All right. Great. So now it'll be a gradient from red to green. Okay. So one more thing we need to do is add in a math converter, and we're going to okay, so one thing I want to do is I want this value down here to be 0. So in order to do that, I need to first determine what the lowest value here is. So hit N so we can see, and we want global location. I guess global and local are the same right now. Oh, right, because I haven't subdivided these. All right, so it's negative 3.11111. Copy this value. Yeah. Okay, so now we want to subtract that value, right? Because then 0 become, or negative 3, no, we want to add this value so that this will become 0, the 0 point. Okay, and then now we want the range to go from 0 to not 1, but like 6.222. So it's going to be this times 2. Okay, so now if we were to move this, oops. I didn't mean to add, I meant divide. Yeah. Good, so now down here it's red, up here it's green. That's exactly what we want. Now the reason, now we need to use the subdivision of the faces to get each of these little faces to be a different color based on its own position. So to do that, we're going to, let me just, that'll be fine. I was going to save, but I'll just redo it if it crashes. So we'll go into edit mode, select all the faces, Control E, Control E, mark sharp. Now we get add a modifier. Hang on, I want to make sure. I think it should be fine, but yeah, that's fine actually. All right, edge split, uncheck edge angle, back into object mode, apply. Now we should be able to move a face and it's free. So these are all loose parts now, which means we can select all of them, hit P, separate by loose parts. And now if we go back into object mode, this is a loose part. But if you notice, they all have the same origin. So I can move this, right? But its origin is still there. So if we look at this in material mode, nothing has changed. So what we need to do now is select all these and change their origins. So Shift, Control, Alt, C, and say, what is it? Origin to geometry. Boom. Okay, so now they all have their own individual geometries, and we have a nice little graph of our Lagrangian. All right, so this shows now the color represents the value of the Lagrangian, which is L, which is kinetic energy minus potential energy. And this is the Lagrangian for a mass spring system. In the next video, I'm going to get into some of the next steps that Eugene takes, discussing partial derivatives in like the x and y direction.